All right, hi guys. So today we're gonna be covering why the angles in a triangle add up to 180 degrees. And so it's really simple. We're given this diagram and the horizontal lines. We're just gonna assume that they're parallel, and we're gonna have two other lines that meet on the top line and intersect. But they both intersect the bottom line at these two other points at the bottom right here. And so using this configuration, just take a moment and pause this video to try this proof on your own. So what we're asked to prove is to prove angle 1 plus angle 2 plus angle 3 is 180 degrees. And using the configuration, can you figure out how we might try to prove this assertion? So just try this problem on your own for a second. All right, assuming that you've tried it, let's just dive into it. So what do we really know about this equation right here? Well, as you might have learned in the session in week 13, we covered that if you have, let's say, a point here on the line P, and we're gonna have two angles that add up to a straight angle, which is 180 degrees. So these two angles formed in green will add up to 180 degrees. We can say that, let's say, if we call these angles 4 and 5, we can say that angle 4 plus angle 5 is 180 degrees. So that might motivate our proof for our triangles in this diagram. So what can we really do in this setting? Well, a really useful strategy is to try to find angles that are congruent to one of the known angles that we have in this diagram. And so, for instance, we know that let's say we know that angle 1 right over here is also congruent to this angle right over here by corresponding angles. And so remember in the session how I said that we don't really need to know this, but it's really useful to see that to kind of know the names at the top of your head, because like these angles do correspond in such a way that this angle, the top angle, forms a V shape like that, and the bottom angle, right, formed by angle 1, also forms the same V shape. And so these two angles must be congruent. So that's like one really nice way to like to think about it. And so we can say that this green angle right over here is angle 1. Okay, so that's nice. How about what about the other angles? And so using this fact that like two angles that form a straight line add up to 180 degrees, can we form a sum of angles that sum to 180 degrees? Well, yes, we can. And let's see how. So angle 3 can be transferred over here to the top angle, angle 3, or yeah, just to the top angle, because these two angles in purple are vertical angles, so they must be congruent. They must be the same. And All right, so we have angle 3 and angle 1, and now we just need another angle to finally prove our assertion, and that's our angle 2. And so remember how we said that angle 1 is congruent to angle, well, the angle at the bottom left is congruent to the angle on the bottom, the top right, sorry. So we can kind of use the same logic to say that the angle at the top left is congruent to the angle at the bottom right. And so this angle right over here must be angle 2. And remember, this all works because of the configuration that we're given here, because this is these two lines are parallel. And so now we can actually just finish it off by saying that since these three angles add up to 180 degrees around this point, I guess we can call it P. We can actually just say that our angle 2 plus angle 3 plus angle 1 is 180 degrees, and then obviously rearranging it gives our assertion right over here, and we are done. Thank you so much for watching, and hope you have a nice week ahead of you.